All right, welcome back. We are INFR3110, Game Engine Design and Implementation in the Fall 2020 semester at Ontario Tech University, and it's week 10, part 1 of our broadcast. We're talking about gameplay systems today, and we'll go into detail about what that is in a few minutes. First, let's talk about what we've got going on today. So we're sitting at week 10. It says checkpoint 3 and individual assignment 2. When I spoke to the TA, he says that the individual assignment will probably happen coming up, this week on Wednesday. So I would look for it on Wednesday, November the 25th is my guess, is when the individual assignment will come out. It's going to be, again, fairly straightforward, something that you can do within reach, I think, for the stuff that you need to do for this course. And then that'll be the last kind of individual piece. We don't have very much time left together in terms of total time. This is the third, or I would say the second last lecture. The last lecture is next week on Friday, and after that there won't be a lecture the following week, but rather your final presentations for your semester project, where I'll give you your mark for your semester project at the end. Okay, so that's what I want to do with you guys. So again, this is checkpoint 3. We have 2 short weeks from the final, and this will be the same week, I believe, as JamesCon, right? So we'll see how that goes, and you guys will be ready to present to me. All right, so that's where we sit right now. Let's talk about what we did last week. We talked about human interface devices, and we had a bit of tomfoolery with my in-class exercise last week. Thank you very much for sticking around. We actually did a way longer example than I had planned, but thank you for that. It was fun. And this week, what are we doing? We're doing Project Checkpoint 3, where I get together with you guys and your teams on Discord. We'll do this after this lecture. And then Intro to Gameplay Systems, what that means. And I'm going to talk about a procedural world generation just a bit. It's kind of a topic that's close to my heart in terms of what I want to do, especially for the things I'm working on as a grad student. Right, so I'm kind of doing that. And then in-class exercise 6 is linked with procedural world generation for you guys as a GDW group. So while I'm doing something with all the teams in Project Checkpoint 3, I've given you guys a little task to do for bonus points again. For, if you're interested. I think it's an interesting little task, and hopefully you'll have fun with it. It'll be due tomorrow night at midnight if you want to get your bonus marks. Okay, so that's the challenge. Before we begin, are there any questions? Hopefully not. If you do have a question, please let me know as we're going, and then I'll stop. But let's talk about gameplay systems a little bit. And again, I don't want to take up too much of your time because I want to also meet with you individually for your checkpoint 3. So gameplay systems. So far we've been talking technology. Everything that we've been doing is all about technology. And, we know that game engines are complex, layered, and it's built on top of hardware, drivers, your OS, all that kind of stuff. So it's kind of a machine with lots of dials and switches and everything else that you build. If you're going to build a game engine from scratch, the subsystems would take you quite a bit of time to figure out. And you'd have to really think about design patterns and a bunch of other stuff that we've talked about this whole semester. As a reminder, when we think about your final exam for that week, and during our exam week, remember that there's going to be some theoretical questions. It could be short answer, your thoughts on some of the things that we've been talking about this semester. I might give you something to think about, a problem to kind of work through, right? Something that is not requiring things like coding in any way. I may ask you for a UML diagram, those kind of things. Now, the great thing is you'll have access to all of the PowerPoints, of course, as normal. It'll be open book, and you'll have 2 attempts. Chances are I'll probably give you 2 attempts to answer it'll be like a little quiz, and I'll take the best of the 2. Now, it doesn't make sense because I'm going to have little Q&A, and it'll be mostly the same result. It's not like you're going to have more than one type of exam. There might be some random questions you get, but the random questions will be like, minimal. So you might want to ask, I might just give you an option to answer question A versus question B anyway, and we'll see how that goes. But so there is the theoretical part to the exam as well as some kind of practical piece. So again, two-part exam, that'll last or span during our exam weeks. I say weeks because I may release one earlier than the other to give you guys a break. All right, so it's not going to kill you. Anyways, going on. So we know it's complex, but we know that what game engine system components do for us, right? There's low-level engine systems. They provide all kinds of services for us, right? So subsystems, human interface devices we talked about last week. We might have a rendering engine that produces graphics on the screen, an animation system, a collision system that's maybe tied into the physics engine, an audio engine. We have all this other stuff, but despite all this stuff that we've been talking about so far, there's still no game. There's still no game. And so this week we're talking about gameplay systems and how that ties in. So really, it's not defined, a game is not defined by its technology, but rather by the gameplay, right? So, and of course the experience, the fun experience of playing the game. So we've been hearing game mechanics bantered around through your design courses and through GDW and a bunch of other stuff. Game mechanics mean different things to different people. For us, it means a set of rules that govern the interactions between the various entities in the game. And you can see that this is the subsystem, our player mechanics subsystem that ties into the state machine and animation systems, camera controls, and your human interface devices, your collision manifold, your movement systems, all that stuff is where your game mechanics ties into, right? And it really, for us to have a game, we need to have objectives for the player, criteria for success and failure, so some kind of win condition, lose condition, those kind of things. Players' abilities, some kind of ability, especially as we go more and more towards role-playing kind of type characters or more characters with abilities. Different NPCs or non-player entities, could be instead of non-player characters, other things that are in the game that can help or are neutral towards the player, as well as enemies that are against the player. Some kind of obstacles or hazards, those kind of things are all part of a game, right? And of course we also have to talk about the overall flow of the gaming experience, which is just your whole visual appeal, the dynamics of the game, all that other stuff. All right, so that's what we're talking about here. Many games also have stories, and Kennedy, this is just for you, right? If you like stories, right? So if you haven't had a chance to, and for those people who are also involved, who are writers in the group as well, I personally believe you can't really have a great game without a story. We may have talked about this before, and these are a few slides that I've taken out of another presentation that I like to do about story, but I wanted to bring them here because I think if you have a rich cast of characters in your story, whether the game is itself the character or whether each, you have a group of characters that are clearly defined, I think it makes the game far more interesting. And most of the time, this is a great template to use, which is the hero's journey. And the hero's journey really is broken down into several acts, which you guys have seen before. I'm not going to go into it again because it doesn't really belong necessarily in game engines. But I wanted to kind of remind you, it's kind of linking back to the design courses that you've done before, maybe in the past, or other courses that you've connected to that you may have seen the same, kind of model, right? So remember when we talk about the hero's journey, we have these 12 steps that are defined by our famous author, Joseph Campbell. The ordinary world, where the hero starts off. Luke Skywalker starts on Tatooine. The call to adventure, as an example, we have Obi-Wan Kenobi back in the Star Wars days, comes to Luke and tells him you have to leave Tatooine. The refusal of the call, I can't, I have all these power converters. And then meeting the mentor, as an example. Well, that's kind of linking in. The mentor, in this case, for Star Wars, if we're going to break it down, is presenting the call to adventure. Sometimes the mentor is separate. Usually there's some kind of threshold guardian, people that stop the hero from moving to the next stage, and usually the threshold guardian at Star Wars is his Aunt Beru and his Uncle Owen. They say, come on, Luke, you can't leave. And he's even his own threshold guardian. That's what's going to stop him from accepting the call to adventure. Then you have test allies and enemies. Getting off of Tatooine is, he has to go to the most wretched hive of scum and villainy, Mos Eisley Spaceport, where he meets his first ally, Han Solo, Luke Skywalker, and Han Solo. They meet, and Chewbacca, and then from there, they've got their first test. getting off the ground, going to, trying to save the princess, all that kind of stuff. And then finally, the approach to the innermost cave, as an example, happens. Now people have different opinions about this for Star Wars. Sometimes they think that the innermost cave is the Death Star. Some people think that the original Death Star, when they went there to save Princess Leia, was part of the test allies and enemies phase, and then the ordeal is really destroying the Death Star, believing in the Force for Luke, and all that kind of stuff, seizing the sword by destroying the Death Star and accepting the fact that he's a Force user, and then the road back, being saved by his friends. The friends would step in to save him, and the road back, sometimes the hero might die and come back to life. In this case, he almost died. Darth Vader almost, destroyed Luke in the trench, the Death Star trench, but he was saved by his friends. And then returning with the elixir, returning with the prize, where they have, where Chewbacca never got a medal, and all that kind of stuff, right? So, kind of an interesting, set of parameters. There's a little video that I've linked to this if you're interested in watching a really quick and dirty, the hero's journey thing, which is kind of cool. Take a look at it if you're interested, if you're a writer. I also recommend a couple of books if you're interested to read for a story, and this can really help your game, because I think it's good to wrap a game around story elements, right? So Joseph Campbell wrote the first book, or the original, The Hero with 1,000 Faces. Very complex, I would say. And he is very detailed in terms of the way he just defines his monomyth and everything else. But I think, Christopher Vogler, when it comes to writing not just screenplays, but in general, he kind of decouples the whole monomyth and the hero's journey in his book, The Writer's Journey. So if you're interested in writing, or if you want to add story elements to your game, highly recommend reading a book like this. The Writer's Journey is a great book, and it kind of talks to all the things that I just spoke about in these few slides. Okay, so that's for the writers in the group. So you've got your story elements, and now we got to think about the game world itself. Once you've got your story elements, we move into structural patterns for gameplay, right? So we want to, create elements, different kinds of elements in your world that we're going to be talking about. Let's talk about those. So there's basically two types of elements, and there's numerous discrete elements, but the two types that we talk about a lot when we talk about game construction, if you will, and I'm talking about it not from a design perspective now or a story perspective, but rather a game engine's perspective. We talk about two types of elements: static elements in the game and dynamic elements in the game. And static elements would be things like terrain, buildings, things that don't change, roads, backgrounds, skyboxes, all that kind of stuff. Dynamic elements would be more like characters, vehicles, weaponry, power-ups, all that kind of stuff that it talks about here. So dynamic elements definitely are more costly, I would say, from a game engine perspective, because they need an update a lot more times than static elements that are props, perhaps, or platforms in your game. And here's an example of that. You might be able to separate the dynamic elements from the foreground, from the static elements in the background, to compose a scene that has both in one place, right? And that's a lot of times what you can do. You can block out a scene with nothing in the background, as an example, and then eventually compose everything together. And what this does, it does a couple things for us. One, it allows us to create a separation of concerns again, where I can use division of labor techniques, where I can say, okay, so I've got my background level artists, they're going to do this. I got my people who are working on the foreground, so things like animation artists, modelers, those kind of things, and other aspects that are active in the foreground, gameplay elements that are active in the foreground, traps, hazards, enemies, AI, all kinds of stuff that are linked in the foreground. And the dynamic foreground takes, like I said, a lot of work. So really, we frame the entire game with static elements, so things in the background, and then we have dynamic elements that work, in the foreground to accomplish, to achieve things like the objectives of the game, to achieve the win condition, as well as, to suffer from the lose condition, whatever that is. So here's some examples. We got a game here. This is Gears 5, which is kind of a classic now cover-based shooter, I would say. Cover-based shooters, you know what? They've really taken a beating over the last little while. I'm not sure that they're as... some people would say that they've ruined the 3D shooter kind of genre in general, just because they've been so, overused in terms of, how this would work. I'm not sure. I'm not convinced about that. I think they have their place. I think they can be just as fun. In many ways, I always think about cover-based shooters, especially a shooter game like Gears of War, which is in a sandbox. It's not really an open world necessarily. It's similar to me to a rail shooter, where you're kind of you got one enemy after the other, and all that kind of stuff, and you don't move too much. Here, you're moving, but you're not really moving. You got the illusion of being in a big world, but actually you're not. You're really on pushed. You're prodded from one scene to the other, and that's how the game functions. And we can talk about game state, right? So dynamic elements, they worry more about game state than and this is the current state of all dynamic game world elements taken as a whole compared to the static elements. So this is where, again, dynamic versus static, I would say there's just so much more involved from a dynamic elements perspective, and they eat up a lot of our resources from a game engine perspective. All right, so when we think about the ratio between the two, again, we've talked about how dynamic elements are more expensive than static elements in terms of CPU resources, memory usage, and so on. And we're still constrained, even though we have much beefier hardware setups these days than compared to, let's say, 10 years ago. We still have this constraint of memory and CPU utilization and performance, right? That's kind of, what's out there still. So because of that, we have to kind of carefully balance between static and dynamic elements. And some of the things that we can do, we can pre-bake a lot of the stuff that we see on the front end, dynamic elements, right, ahead of the scene generation, so that way they don't take up a lot of CPU cycles. That's the idea behind them, right? So again, let's think about this. Even though gaming hardware has become more and more powerful, what's been happening is to compensate for this, the game companies are pushing games to become more and more realistic and a higher and higher dynamic to static ratio in terms of dynamic to static game elements. Okay, so again, let's go back and review that. We have two things. We have lots of stuff in the front end that need dynamic updates, and stuff in the back, or somewhere where I might have things that frame my game that don't need as many updates. And now, because we want more realistic elements, even things that should be static, the skybox and those things, we use things like post-processing effects, we use bokeh, we use all kinds of things so it lights our scene and creates, maybe even overuses things like bloom and other things in the post-process to make it look nicer. And so things that are supposed to be static are starting to become more dynamic as well, right? Making more realistic looking, more demands on the hardware, and so on. So we have to be really careful about how we set things up on the game engine. And this all comes back, that's why I talked about story, this all comes back to story elements. Story elements really start, kind of directing us in terms of what the game is going to be about, and what are the requirements of the game, how the mechanics are going to work with the story, and then what are the hardware requirements as we get into this fight or this ratio between dynamic versus static. And just as a side note, has anyone got their PS5 or Xbox Series X? I haven't been able to get them. They've been completely out of stock. Anybody curious if you're even interested in getting one of these consoles? I am, but you don't have either. Yeah, I know, it's a thing. for me. You know, whatever. I need to get a couple of them. You've got the Series X? Oh man, I am like so jealous, Christian. What's going on with that? Tell me a story about the Series X. I'm thinking that more about that than right now. PS5. I mean, Kijiji for $700. Wow, that's awesome. There's no smoking. I keep seeing that the Series X smoking from the top like a chimney, right? And on different places, right? So PS5, Thaden, and it's massive. Yeah, I've heard that it's massive. You know, that's one of the things that has been, there's a lot of comments from a design perspective that is so bad. And just curious for the people who own these new consoles, backwards compatibility, yay or nay? How are we doing with that stuff? 100% works. Yeah, that's good. It's great. Awesome. That's great. I'm looking forward to it, guys. Hopefully we'll have that the stuff. The smoking Hexbox is a hoax. Come on, Craig. I saw it. It was on Twitter. But anyways, I'm super excited about these two consoles, and the big for me, they're blowing vape. That's funny. They to me is what I'm really looking forward to seeing is really the performance of these next gen consoles. And when we say next gen, remember these things are going to be with us, guys, for the next 10 years, because usually that's how long they last. Xbox and PS5, pretty much every 10 years we're going to get a new one. I'm not sure if this is going to be the last gen. That's another thing we've been hearing about. You know, next gen, but also last gen, right? Because and Anthony, that's right. Xbox is looking like more of a PC now. Some concerns have been things like airflow and heat and a bunch of other stuff that we've been talking about. And I'm still waiting for more and more reports to come from those, kind of some of the YouTube sites out there that are going to report on this stuff. But what this is going to do for gaming is that game companies are going to definitely move things forward. And what's going to end up happening is that, we're going to be able to push the limits of some of our subsystems in our game engines, whether it's a commercial game engine like Unreal or Unity, or some of the game engines that are being run by the big studios, right? So that means we're going to be able to push stuff. We're going to see more things. And what's going to end up happening for us is what we're hoping is that there's going to be, more realistic effects. Again, I don't mind realistic effects as long as the realistic effects have a meaning, a purpose, and I'm putting it out there for you guys for a reason. You know, it's like nowadays, game engines and playing games have replaced movie going, really, especially now with COVID, more than ever, right? So it's another form of entertainment. And if you think about this, if I go to a movie theater, and when we used to go to movie theaters, and we used to watch a show, right? Then, sure, we might have really cool special effects. You might go to a show for really cool special effects. But if the story really sucks, then who cares about the special effects? It was cool, bing bang, you saw some stuff, it was loud, lots of lights and so on. But then afterwards, you might feel let down, right? And this is what my concern is for when we ramp up the hardware and we're like, oh yeah, cool, we have this cool hardware, we can really turn on like ray tracing and path tracing and all this kind of stuff, and we want to see all this new thing that are coming out. But then if the game sucks, who cares, right? To me, it's like, it has to be a balance. I also think about, for me, it's realism versus playability. The more realistic a game looks, like I said, and we've talked about this before, it can look really realistic. It can play really, really realistic. But if it's terrible, from a gameplay, a balance perspective, who cares if it's ultra realistic and it looks like, it's very immersive if it plays terrible? It's got to be a balance, is what I'm saying. Kyle says it won't be the last console generation, but the next ones might not feel significantly advanced. Starts ramping up with 5G. On your phone, on mobile devices, as well as even to our homes. We might decide to to not require a big system like this, so we can play on any platform. And I think that's where the future is. I think the future is play anywhere on any platform. And I think that's why the idea behind xCloud and Stadia and even all the other players that are going to get into the market, with Amazon and so on, I think it's going to be, eventually that's the way it's going to go. I think that, consoles are going to, go away, right? So it might be computers, but it could also be, it may end up being phones. It could be mobile devices. It could be whatever. And I think what it's going to do is it's going to unlock our ability to play and to be entertained anywhere, right? So I think that's where it's going to go. But anyways, let's continue. So we've got this. We talked about dynamic and static elements here, and it's hard. Like we said, they cross the line sometimes. The one thing about static and dynamic, when we talk about static and dynamic, is this one thing, which is for static elements, we can do less work. There's less updating. We can do a lot of, like I said, pre-baking and stuff like that, even on dynamic elements, to reduce the work we're doing. The less work we're doing, the better performance we're going to get, typically. All right, that's how it goes. And the less realistic it's going to be slightly, but also maybe more playable. Different static elements, different versions. Let's talk about static elements again. When we think about destructible environments here, we might have different versions of every static element, right? We might have an undamaged version, a damaged version, and a fully destroyed version. Okay, so you might have that, and that is actually a really quick and dirty way of creating a destructible environment, right? The idea behind it, right? Which is kind of what Minecraft does, right? You have this, kind of semi-destroyed version or damaged version, and so on, and then fully destroyed version, which just explodes, right? That's kind of what happens here. And Minecraft's really made a comeback, right? They keep on adding additional mods, and they've moved things forward, and they keep doing that over and over again. Even the latest versions, have continually added things like realistic lighting. If you have a card, GPU that supports ray tracing, there's mods out there that can take advantage of it, and so on. I think there's some really great things out here. But a lot of the stuff that they can do in Minecraft, and this is a fully kind of a destructible environment if you think about it, for the most part, they do it with these simple ideas: undamaged, damaged, and fully destroyed. Right? These different states, if you will, for the static elements in the game. And when we think about this static geometry, there's different ways to do that. A lot of times we can use tools like Maya and Blender and a bunch of stuff out there, to basically create something called instance geometry. And we've actually talked a little bit about this when we discussed the flyweight pattern earlier this semester. The flyweight pattern, again, takes advantage of both extrinsic and intrinsic elements or properties, if you will. And what we can do is we can separate or decouple. Remember, we talked a lot about decoupling patterns this semester. We can decouple the extrinsic and intrinsic elements or attributes of an object, where we can instance a bunch of elements, maybe on the GPU or even on the CPU side, in order for us to save memory and from an optimization pattern perspective, right? So again, we might have, here's an example. An example is that the 3D modeler might create 5 different kinds of short wall sections and then piece them together in random combinations in order to construct miles of unique looking walls, right? So let's continue. So again, when we think about instancing again as a memory conservation technique, think about this image here as something that might happen. We might have, let's say thousands of trees in the forest, and with a little bit of adjustment in terms of, how they're positioned, the way the billboarding is used, if you're using a 2D image and you're billboarding it, and so on, it could give the illusion that there's a lot of variety. And I think this, again, going back to static geometry or static elements, we can do less work and produce a more realistic effect. Okay. The other thing we can do with static geometry is use something called brush geometry. Okay, and actually Unreal is great for this. So when we have a brush, it describes really a shape that's a collection of convex volumes, each bounded by a set of planes. And what we can do is we can use them to rapidly block out the contents of a game world. So actually you can do this in Unity too, but Unreal has this idea of this brush geometry that you can use to block out your level. All right, so blocking out your level is a great idea. Why? You can tell if the level is going to work ahead of time with less coding involved. I can block it out. You can do this even with like other tools, like we said, with Blender or with Maya or your favorite 3D tool. And what this allows us to do is pre-visualize what the game is going to look like. Actually, there's a huge department right now that's been forming over at in the cinematics department of Ubisoft, which is the previs department. Again, I have a friend of mine that works there, and in the previs department, what they do is they use the grease pencil, right? So the Blender grease pencil to create the scene in 3D, add elements from a blocking perspective, block out the scene by using actual assets and props in the scene for what the game that they're making, change the scene, adjust the cameras, create a real looking camera rig inside of Blender where they can block the scene out, look what it's going to look like, and actually create the cinematic, whatever that cutscene is going to be, way ahead of time with no code. You can have a director that can go through and direct the scene, right? And we can create things like 3D storyboards and all that kind of stuff with this idea of using brush geometry in the scene way before the game is constructed. So really cool stuff that's happening. Let's take a look at world chunks. Oh yeah, world chunks. And we see a lot of this happening. Loading screens, right? So we have a very large virtual world, and we more and more now we have these open world kind of games or seemingly open world games that are very large. And when we move from one scene to another, a lot of times what we have is a loading screen. Now, it's not just a loading screen like this that loads the game, but actually some kind of loading screen, even whether you're in Skyrim, you're moving from an outside scene to an inside scene. As an example, in any of the Bethesda games, actually as an example, you would have the loading screen. Why? We're going to talk about this idea of world chunks, right? Or this idea of just discrete playable regions. It looks like you're inside. You've moved from an outside scene to an inside scene, but actually it's a whole other level. Okay. So really what's happening is, chunks are also known as levels, maps, stages, or areas. And the player can only see a handful of these chunks at any given moment while playing the game. And they progress from chunk to chunk as the game unfolds. And I know maybe you don't like the word chunk, but that is actually a thing, right? World chunks. So think about this. The original concept of levels was invented as this mechanism to provide greater variety in gameplay, right? The idea that, we have some memory limitations, and what we want to do is allow the player to move from one goal, a level with a goal, to another level with a different goal. And actually what it did was, through this limitation or constraint, it created an idea of progression. It created the progression, and it actually created a more richer game experience by going from one level to the other. Okay, so that's what kind of it did with this idea of world chunks. Okay, so again, it happened maybe by accident, because maybe we needed to work on memory. We can't display the entire world at once back in the day. Right? Even now it's hard with all of our realistic lighting and other dynamic elements now that proliferate our scenes in modern games. Right? So we still have to have the loading screen, at least for now. In the future, that may not be as prevalent. And even when it does happen, if you think about this, now with the PS5 and the Xbox Series X, many people are reporting, the people that have those game systems, that loading screens the times for them have been greatly reduced. They're super fast, and they're not even used to it. They don't expect it to load so quickly. So maybe it's going to come to a point in time where it's so fast there's no loading screen anymore. Other games use other kinds of topology. So instead of it being linear, as an example, from one place to the other place, right? So you're going from, let's say the game elements go from level 1 to level 2 to level 3. You may not have a linear topology. Maybe you have more of an opportunity to go to different places in the game that maybe become unlocked after they enter a different chapter. And we'll talk about chapters later on. Here we're at New Tristram. Yes, you're right. It's Diablo 3. I'm waiting for Diablo 4. I really like these kinds of games as well. And you know, you've got this idea of a hub and spoke kind of idea where I can go to any one of the areas I've visited before. And I think it's really starts at 8 tonight. Darn. So, you know, you can go to any one of these places that you visited before. And one thing that Diablo allows you to do is increase the difficulty, ratchet it up, and replay the entire experience again with more difficulty. And one of the things, again, I want to talk about this. Some of the games I've talked about already have a lot of procedural elements in them, dynamic elements that are things that are not set from the beginning. They're not something that is statically set or modeled manually, but rather are procedurally modeled. So a good example of this is you have a horde of enemies that happen in Diablo 3, but you might have a world chunk that you're going to go to, another level, another setting, if you will. But the enemies that you're going to find there are procedurally generated. There's not a fixed number of enemies. And the loot drops that they have are also procedurally generated. So you have random loot drops. This idea of random loot drops, random enemies in the same world setting. So again, some elements that are static and fixed, other elements that are random and algorithmic, if you will, provide a sense of replayability for us from a game design perspective. Linking back to those discussions you had on replayability back when you were doing game design. So pretty cool stuff. And then others, really what we can do is we can create this illusion of a vast open game world. And here's one. This is Shadow of the Tomb Raider, I think it is. Or is it Shadow? Or is the other one? It's the other Tomb Raider game now. But anyways, in the Tomb Raider games that we see, a lot of times we see this vast open world, or even in God of War and so on. It appears to be like a vast open world. And by the way, I look at Tomb Raider and God of War as very similar type of games, right? Because of the way their mechanics work, right? And we use this level of detail. The farther things are, you see these elements that are really, really far away, as an example. And they appear to be like really detailed from far away, but if you were actually able to get close up to those elements, they're not real. They're just an illusion. And again, actually, I like the word illusion when it comes to gameplay, because if you think about it, many of the things we do in games it's all an illusion. It's all smoke and mirrors, if you think about it, right? It gives you the sense of this stuff that's happening, right? So again, doesn't matter how rich modern game designs are, right? Memory limitations are still around, and we still divide our worlds into chunks. This idea of world chunks. And why? It's a convenient mechanism for controlling the overall flow of the game, right? I can define how my game is going to be laid out, okay? It can also serve, like I said earlier, as a division of labor, right? Along with static and dynamic elements, so that I can give each chunk and can be constructed and managed by a small group of designers and artists, almost like a little mini game within a game, okay? I want you guys to work on this level. So imagine if we were going to do GDW, all of us, and instead of you having different teams, my friends, you're all part of one massive team. Actually, I was talking about this today. You have this one massive team that you're working on, and each team is working on a different level for the same game that's being constructed, okay? This idea, almost like a simulation of what it would be like in a larger studio. So let's say 40 of you are working in a team, not 6 of you. So then we could divide the labor. We can say, well, guess what? We're going to chunk the world up, and we're going to give one world chunk to this group and another world chunk to this group. So smaller groups work on the world. We share resources, assets. We share things like mechanics, tool sets, all those kind of things. And at the end, we create a game that is pretty awesome. Okay? It can happen. And this is what happens in small studios with 25 to 40 people. Or even on larger games, right? Imagine instead of having, like it says, a small group of designers and artists, you have a group of 40 people and they're working on a small chunk of a much larger game. So we can think about world chunks kind of like that. We see a world chunk here. This is part of the game. As an example, you can see that here, this is a game that's been blocked out. I'm working on this part. And there's a chunk over here, another part of the game that you can get to when this part is unlocked. You unlock the ability for us to get or bridge over to this game, this part of the game. And it's like there's two different game worlds here that are kind of linked together by some kind of connection, right? Going back to what we said earlier, it's like that whole hero's journey. The journey itself, right, is so interesting. It's going from the normal world, where the hero starts off, into the special world, where the hero learns, or the heroine learns things about the world, and so that they can be the master of both worlds. The future world, the special world, and the original world. And once they become the master of both worlds, they move on to the next game. So instead of just Destiny 1, you're moving on to Destiny 2. Instead of Oblivion, you're going to move to Skyrim, and so on. And then that's how the companies try and structure it, so that you've already progressed. You've leveled up in a game, and you want to do it all again. Actually, it comes down to this whole idea, if you think about it, when we played Dungeons and Dragons, a desktop role-playing game, right? A tabletop role-playing game. We start off at level 1 in Dungeons and Dragons. You go through your campaign with your dungeon master. He brings you to a space where you are a higher level character, and then you might want to do it all again. Start off at level 1 again and do it. Because the fun of making the character is part of the game. And in fact, a lot of that has been captured in modern role-playing games and in modern shooters and everything else. You have this part where you create your character, that game within a game, which is so fun. All right. So really, the high-level flow really of a game defines the sequence, or think about a tree or graph of player objectives. So you have a bunch of objectives, and how do they tie into your game world? How do they do that, right? You have your game world, it's broken down into chunks, and you want to tie your objectives to those chunks somehow, and you want them to connect, all right? So think about these as tasks, stages, levels. Again, they're very similar to world chunks. Or waves. Here's an example of a wave in Minecraft Dungeons, where you can have one wave and then there's another wave that comes back. We see a lot of this happening in games like Diablo as well, or even in maybe a failure that we've seen recently as well with Fallout 76, right? Where we have these kind of events that happen, or even in Destiny 2, where we have an event and you have a wave after wave of kind of enemies that come at you. And once you're finished, killing all the enemies, wave after wave, then you're done that event. You've completed the event, as an example. And these public events are things that are tying, kind of our games together these days, because it allows us to do multiplayer missions as well as single-player missions together, right? So that's kind of cool. So really cool options for us. Let's take a look at this. So when we think about this, we want to, from a high-level flow perspective, we also want to define success. What is success? And we want to start defining each objective. And this is one of the things that I've asked you guys to do, which is in this semester, which is I want you guys to create a tutorial level, right? The tutorial level is really key. And this is the, your group assignment 2 that you've been working on. Group assignment 2 really is something that's pushing you to create tutorialization and a quest system, right? And the quest system is really key for us, especially in 3D, when we get a sense of accomplishment. We can check off different aspects of our game that we've accomplished. We can move forward and have a game that feels rewarding for the player. Because remember, each feedback we get, if we give a player feedback that they're doing the right thing, we're training the player to do those same actions over and over again. We can't train the player unless we've given them feedback, right? And there's different kinds of feedback. We can give feedback in terms of you're dead, right? Or you ran into some treasure, as an example. You've kind of discovered loot, whatever it is. There's some rewards right from what you've done. You've killed the baddies. Here's some rewards, loot. But we can also give feedback in terms of, hey, let's check off all of these items that we've asked you to do. You've done them. Great. You're well on your way to being a successful character in our game. This is the kind of stuff that we want. Here's a question that comes from Roderick. Do we need to just show the current step, or do we need to show the whole list of steps? I think it's good to show in a kind of a smaller quest. Like, for example, here's this quest here in Borderlands 1, the road to Sanctuary, right? So kind of, a smaller quest while the player is just starting. This is kind of like, he's like, look here, the character's level 7, so like early on in the game. So in the early game. And then, he's got to learn how to, or she has to learn how to use catch a ride, get a vehicle, go to Sanctuary, and then this whole little piece is the road to Sanctuary. So you have a small quest like this. I think it's important to show all the steps. I think it's good to kind of show the checklist, all the things that have been completed, right? But I think when we move from one to the other, I think the quest system should be flexible enough to kind of again create these little chunks, so that you only see the things that are relevant to the little quest that you're doing at this point, and maybe in the larger mission. Again, when we think about that, and hopefully that answers your question, Roderick. When we think about that, what we're really saying is, I want each of my quests, each of my training, each parts of my training to tie into the larger story elements, right? The larger story elements. Because if we tie them into the larger story elements, it's a cohesive whole. It becomes consistent, a consistent gameplay experience for us as gamers, right? We want to see that. We want to see feedback coming at us that we've done something right. And we want to see it regularly. The more regular feedback you give your players, the more they're going to play your game. Okay? If you never give feedback to your players about how they're doing, again, there's different games like this, right? It can become really harrowing, right? Especially if they're not accomplishing these little goals. Nowadays we want to accomplish little steps, little goals to our bigger goal, right? And it'll encourage you to build up your skill set, to train your players to do what you need them to do, and at the same time, kind of introduce new mechanics in a timely way in order for them to be successful in the game. All right, so that's kind of the way it should be. Again, not for all games, but definitely for the vast majority of games out there. We also have something else. Nowadays, like I said earlier, games are replacing movies, right? In many ways. A lot of people, they prefer to play a game over going to see a show. Why? We spend the money, and I've talked about this before as well. We spend the money to go see a show when, pre-COVID, and it's going to equate to like $35 Canadian as of this recording, something like that. For you, for some food, snacks, whatever, and to go see with somebody else. All right, even on your own, it becomes very, very expensive, right? And it creates this, entertainment experience, right? Well, so do games nowadays, and a lot of nowadays, more and more, and I think probably most AAA games nowadays include some kind of cutscene or in-game cinematics. We just talked about the whole pre-visualization thing as an example, and what we do is we render all these scenes offline in its own little movie. So all the stuff that you've been learning with Gavin in animation, and in all the stuff that he's been doing, you can put together this full motion video or movie, right? That it's a cutscene for your game. And I think this semester is the semester that he's asking you to do that kind of stuff. And if you can do that, I think it goes a long way to doing two things, right? It kind of gets us to show the backstory of what's happening in the game, to give the character, the player, a sense of where they are from a story element perspective. I think this is really, really important. At the same time, it allows us to understand where in the game world we are, what we've accomplished. Another way of giving feedback to the player, because we're showing them, hey, you've just unlocked a cutscene. This is pretty cool. You've gotten to this point. Now, I have to also talk about the negative, which is many of us just skip the cutscene. Hey, it's just hands. I just want to know from a checkmark perspective. Checkmark in the participants panel. Who skips all the cutscenes? It's okay. Don't be afraid to say it. There's other people out there that do that, right? Okay, X means no, you don't skip the cutscenes. But there are people who just never see the cutscenes, right? They don't even look at the cutscenes. They just want to get right to the action, right? So if there's people out there like that, it's okay. Don't be afraid to put your, to check off yes. And I see some people have done that. And people are saying, yeah, it depends. Why? Because cutscenes, in some ways, thank you for that feedback, guys. Some people, you know what? some people think of cutscenes as actually, instead of actually increasing the immersion, a lot of times what they do is because they take control away from you as a player, right? You can't really be part of a cutscene right now anyway, right? A cutscene is static. A cutscene has been filmed beforehand, right? With maybe actors and, in motion capture suits and so on, right? And what's happening is you're outside of that whole action. Normally in a game, especially a AAA game, you're in the action. But a cutscene or a full motion video takes you, or a cinematic, takes you out of the action. And now you're watching something. You're a passive player in the game as opposed to a dynamic player in the game. And this is where people skip the cutscene because they don't want to just watch. They want to participate. It cools them down too much. They want to be hot in the action. They want to be immersed in the gameplay. And this cutscene is okay to see, as an example at times. But a lot of times it's where you put the cutscene. And a lot of thing is the cutscene, if it's located in the right position of the game, it's a place for you to rest. The best place, in my opinion, to put a cutscene is at the end or at a place in the quest where you're actually resting your character, where you need to rest, right? It's part of the story. If you're resting your character and then you're showing a cutscene, and it has to be pretty quick, right? And you should always give your player the ability to skip, because the best place to do it is, again, during these periods of rest. And it's good to have contrast. I mean, movies also use this idea of contrast when it comes to a high amount of action, right? And then a lower, kind of a falling action. And falling action, this idea of falling action, is what happens with cutscenes. We have a lot of action. We have a rising action. You're going to the, kind of the fight scene or whatever with a lot of video games. And then you're done. You've defeated the mini boss. And now you're into this falling action stuff where it's, going from a positive to a negative. And the negative, what happens is you're going into a scene where you're getting more of the story. You're getting more of an idea of how to complete the game or where your place is in the game. So again, it depends on how these things are done. But more and more we're seeing this because it's replacing some of our entertainment that's out there and creating additional story elements to cement our immersion in the game world. Okay. Yeah, so if you can make interactive cutscenes, that's cool, right? But we have a while to get there. It'd be really cool if we can do that. But sometimes, people skip those too, right? They're like, interactive cutscene, I don't want to interact with these characters. They're not real. It's just, it's a waste of my time. I want to get into the action. So I'm just putting it out there as both positive and negative. So let's talk about this idea of these chapters or acts. A lot of games are divided into chapters or acts or chunks or levels that we've talked about so much. And we have all of these objectives in our game. Ton of these objectives that we put in. And a lot of this we want to storyboard. We want to kind of create a massive storyboard about the entire, story or the main quest of our game, if you will. And you can have all these objectives that you kind of look at for all these levels and you put them into place, right? One thing that we have to also do is when you run through the main quest in your game, and one day, your game might be massive enough that you want to have this whole, walkthrough or run through, if you will, to check to see if the character A needs to get all those objectives in order for them to pass from one chunk, one game level to another, as well as you can see optional objectives or side quests, if you will, that allow us to gain, to get the player to have more interaction with the game world. Give them other options in terms of equipment and loot drops and experience, and to make their game a little easier in some ways from them to go from one objective to the other. For example, let's suppose I'm at objective 2G over here, and I'm in chunk 7 or world level 7. I want to go from objective 2G to 2I. I can go through 2H if I want to. Maybe I'll get some more experience and get myself some more loot, as an example. Or I can go straight to 2I if I want to do a kind of a fast run through. It's really up to me. Or maybe I'm going to go do this thing again, replay the game with a different character, different options, and maybe I'm going to try some of these side quests later. Or maybe I'm going to go through the entire game and finish the main quests, and if the game allows me, and I'm hoping it does, allow me to go back through the game world and pick up all the side quests that I missed the first time around. All right, so really cool Again, it makes the game last longer, and it gives us a chance to replay some of those cool elements that we played before. So this high-level game flow idea. All right. And then, of course, we have, we want to implement these dynamic elements, these game objects, and we're going to do it through some kind of tools. Okay, so here's how we're going to do it. We're going to use a world editor. Every tool that's out there right now, every commercial game engine right now has some kind of world editor. Here, I've just taken snippets from Unity of the latest versions. You can see that we're editing a character here, a game object in the game world, or some kind of environment, right? I'm using a world element to manipulate these elements, these dynamic elements and static elements in the game world. And I can do two things. I can visualize how the character is going to look. So this is more of a high fidelity block out. Right, so I've blocked out things earlier with kind of a low fidelity blocking. I've kind of put together elements in the game with no textures, no lighting. I'm just blocking out the game world so I can see where things are going to be in the game world, and I can use I could use Unity for that. I can use my Unreal. I can use a commercial game engine, or I can use Maya and Blender to block it out, like we said, with pre-viz tools. Right here, what we're doing is we're actually testing some of these tools out, testing a game character inside of a game world. It's not quite complete, but we're in a place where we can test out some of the mechanics using this world editor. And of course, we're going to use game objects to do so. And we talked about over the last few weeks things like we can call them game objects. Sometimes they're also called entities, actors, or agents. One of those three things or four things. For example, in Unreal, they're called actors or pawns. Right, whereas in Unity we have game objects. Okay, so just different things. Really, at the end of the day, there's really no standard on how they're called. At the end, for us, we want to think about them as game objects. Dynamic elements of the game that have some kind of behavior attached to them, as well as attributes. All right, game elements that can both be, updatable. They're both updatable and they're renderable. All right, this is the kind of stuff we want. Remember, there's three kinds of game objects. Game objects that are only updatable. So, for example, some kind of checkpoint, right, or a spawn point. Game object that is only renderable. Some kind of background, a skybox, a light, something like that. All right, only renderable. And there's other ones, and these are the ones we're talking about. These dynamic elements that have both they're both updatable and they're renderable. A game character, a enemy actor or agent, whatever, some kind of hazard or power-up or something that you're going to interact with and interactable with the world. So, again, we can classify them as different types, and a lot of times game objects we've talked about before have different attribute schemas that also have different attached behaviors. Example here, we have different monsters. We have a monster class and different monster types, dragon or troll. And each type, the dragon might inherit from the monster class, and the troll might also inherit from the monster class. But these idea of game types or game object types are the things that allow us to create diversity and kind of more immersion in our game. At the same time, we can create a cohesive, object-oriented approach to coding our game, right? And we've talked about that throughout the semester with different design patterns. We can also use, instead of a object-oriented approach, we can use a data-oriented approach with things like dots, which we briefly talked about, as well as the entity component system. A note from Anthony here. An engine interactive cutscene. I like that. We just talked about that. Thank you, Anthony. I'm sorry. I just saw it now. All right. The term game object model describes facilities provided by the game engine in order to permit the dynamic entities in the virtual game world to be modeled and simulated. All right. So a lot of times what we do is we can use we create a class, different classes for different entities. This is not always the case. And although we've talked about this before, and you're like, well, this is nothing new. We've talked about it when we talked about entity component system as an example. Yes, but one thing we know is that when we create game object models, those game object models not only do they extend, the superclass, but they also may extend the game engine. A lot of times, they actually are an extension of the game engine. There's two types of design. There's tool side design versus runtime design. Okay, tool side design is when an object model is defined by the set of game object types seen by the designers in the world editor. And then there's runtime object models, things that are procedural. We've kind of talked about this before, where it's being created at runtime. Some things that are happening at runtime that are not manual. They're autonomous agents that are running around in the world that have, their own life, if you will, in the game world, as well as, chunks, world chunks that have been created on the fly, as an example, to provide, different gaming experiences to players as they play the game over and over again. Okay, so it's tool side versus runtime side. You should know kind of the difference between the two. And when we think about the game world editor, there's different pieces, and we're going to talk about a few of them, only a few of them. One is world chunk creation and management. We've talked about that, how to make a level. Game world visualization, so I can look at the game world as a whole, and as well as navigation, the ability for us to fly through a world. Content selection, which is the ability for us to select and move content around the game world. This is all the stuff that you should have learned this semester using Unity. Different layers, the property grid, multiple object editing, and so on. Okay, saving and loading. And we've already discussed this idea of data-driven asset creation tools like Maya, Blender, Photoshop, and so on. But a lot of times, all these tools do is create individual assets for consumption by our game engine, right? That's what they do, right? So, but where all the gameplay happens is inside, pretty much, it happens through the game world editor. Some kind of tool or suite of tools, in this case for us it's Unity, that provides the ability for us to update and order our game world chunks or levels, okay? And again, all commercial game engines, like we talked about before, Unity and Unreal, have some kind of world editing tool. And if you're going to make your own game engine, you would probably have to make your own world editing tool as well. Think about your group assignment 1 that I gave you. You made some kind of real-time level editor. If we're going to extend that idea, and if you're making your own game engine, what I would ask you to do instead is make your own game world editor, which is closer to what Unity does right now. Okay. So when we think about game world visualization, again, a lot of times in the editor we might see a 4-up view, kind of like this, right? This is very popular in Unreal and in Maya. Actually, Unreal modeled their viewport after Maya in many ways, right? And Maya has also been influenced by Unreal. And there are two tools that have worked together for a long time. So you see the 4-up view that we see here in Unreal is very similar to the 4-up view that we might see, especially even from a control schema perspective in Maya, right? So this is the kind of stuff that we use, and we do this so we can visualize the world from different aspects. I want to have a top-down view, a side view. I want to have a perspective view and an orthographic view. And this allows me to manipulate assets or create assets in the game, and not just assets, but also textures and all kinds of things that we can create and install in our game. So that's game world visualization. Then there's navigation, like we talked about. A lot of times, the first thing I look for when I'm learning a new world editor, for example, in Unreal, I want to see what kind of fly-through controls I have, so I can fly through my world and kind of inspect my world, so navigate through the world itself. By the way, all of the tools, whether you're using asset creation tools like Maya or Blender, or whether you're using Unreal or Unity as a world editor, they have the ability for you to scroll, zoom, and fly through, a lot of times with your mouse and WASD keys, through the world, so that you can do things like object selection and move, kind of movement. Again, things that we all know about. All right, this is the part where we're going to pause for a second. And before we get into procedural world generation, I want to talk about a couple things we're doing today. So I'm going to present this next section to you, part of it is, again, the objective is to give you an alternative option for you to use your game engine, the game engines we've been working with in Unity, to create non-manual levels, right? By using, procedural generation techniques. Okay, and I know this could be teleported into another course, like an AI course, but I'm introducing it here because in your AI course, you're not going to cover it, chances are. All right, so for example, you covered steering behaviors and you covered things like pathfinding and those kind of things, most likely with Dr. Hogue in his animation algorithms course. So here we're covering a little bit of procedural world generation in our game engines course. And then finally, you're going to get things like reinforcement learning and those kind of things in your AI course, which is going to happen in your 4th year, chances are. Okay, so that's kind of the way things are kind of laid out for you in terms of AI. And hopefully, if you're someone who's interested in artificial intelligence, machine learning, and this kind of stuff, some of this kind of stuff can be really, really fun. Some of it can also be another way of, making up for poor design. So again, you have to kind of put it into place where it makes sense and not just, paint everything with a procedural brush, if you will. So again, when we think about what it is, this definition comes from Wikipedia. Procedural generation is a method of creating data algorithmically as opposed to manually. Okay, and I like that part of the definition. Okay. So after I go through this, we're going to stop recording, and what I'm going to let you do, there's a small exercise that I want you to do. I say small, but it's I'm channeling Dr. Hogue today. Okay, so I'm saying small with air quotes, but it's maybe not small. Let's talk about this. Okay, so here's something. I want to use procedural generation, and here's my first method. Okay, I'm going to talk about several methods here of using procedural world generation. One of them is called space partitioning for dungeon generation. We actually already saw this in spatial partitioning, actually, which is part of our game design patterns piece. So, true to its name, space partitioning algorithm yields a space partition. Example, it takes a subdivision of 2D and 3D space into disjoint subsets. And so that any point in the space lies in exactly one of these subsets or cells. Okay, so that's what we're doing. We're creating a cell after we split the world into different parts. Okay, and really what we do is they have this idea of a hierarchy. That's how it works. And this allows us to space partitions to be arranged in a space partition tree. And once we think about trees, right? Any kind of tree structure creates an ability for us to traverse from one node to the other node very quickly. All right, and partition trees, however you want to call them, and there's different kinds. It allows us to do things like more efficient raycasting, frustum calling, collision detection, a bunch of other stuff that this spatial partitioning allows us to do. And the collision detection is what, if we were going to cover, some kind of spatial partitioning from a game design pattern perspective, that's what it covers in our game design patterns book. Collision detection. But here's an example, and the most popular method for spatial partitioning is something called the binary space partitioning tree, which recursively divides the space into two subsets. And it keeps doing that, so that's what the recursive part is, right? So imagine we have a character here, and I want to break the character up into different pieces. We can do that by starting at the root node, and then we divide the character in half, and then half again, and then half again, until we can create something called a binary space partition tree, or in many cases we have other variants of this called quad trees and oct trees. Quad trees usually are they partition things in 2D space into 4 quadrants, and oct trees partition space in 3-dimensional space into 8 octants. Okay, that's how it works. So this is like oct trees. and sometimes they're voxel octrees. My friend Connor always used to say, I want to learn about, sparse voxel octrees, because that sounds like a cool name, right? And I agree, it does sound cool, right? But what it does really is we're partitioning the world, or we're splitting up the world, whether it's in 2D or in 3D. That's cool. I like it. GPC voxel session on Monday. Awesome. That's a great plug. It partitions the world to allow us to manipulate it. So here's an example of where a quad tree can help us define a dungeon. All right. So imagine I'm making some kind of dungeon generation, and I want to use a quad tree by using spatial partitioning. So again, what I do is I start dividing the scene, and then I subdivide the scene, and you can see that this is clearly divided into 4 quadrants, right? Hence quad tree, right? And each quadrant comes from the root node, so one node, and then I keep dividing it in 4. So I can see that this is divided into 4, and I can keep recursively dividing everything into 4 until I create very symmetric, square-ish dungeons. That's what spatial partitioning dungeon generation allows me to do. Because why? I keep on dividing things equally. One thing I can do is I can start off at a very high level where I have some, kind of something that looks like this, or I can move into something smaller where it might look a little bit more random, but it's still quite symmetrical if you think about this when you look at how we can break a world down into these quadrants. So kind of really cool. Here's the algorithm for your binary spatial partitioning tree algorithm. Okay, so you can actually do this BSP tree. Start with the entire dungeon area, the root node of the BSP tree, divide the area along a horizontal or vertical line, select one of the 2 new partition cells. If this cell is bigger than the minimal acceptable size, you got to figure what that is. Go to step 2. Divide the area along a horizontal or vertical line. Do it again, right? If not, select the other partition cell and go to step 4. So if this cell is bigger than the minimum acceptable size, go to step 2. So this is kind of a little algorithm that allows you to do the binary spatial partitioning, which is pretty cool. All right. And what we can get is, and this is another example, here's your tree structure. So there's the root node, so no partitioning. Here we partition it into 2 pieces, B and C. Again, this can also be a directed graph if you think about this in many ways. And here we take A, B, C, and D and E is what B got split up into. B got split up into D and E. C stayed the same as an example. And then here C gets split into F and G. You can split it into different parts, whether you want to do a horizontal or vertical partition, and so on until you get to the place where you have your game world split up like this. Taking it further, you can start injecting rooms into this world. So you're not going to do the entire world as a room, but you put a world or some kind of room in each of these spaces, each of these partitions, these containers, if you will. And then what you want to start doing is connecting the containers with corridors, right? That's what you're doing. So you're connecting the containers, until finally you get to something that looks like this. Again, a very symmetric dungeon, very square-ish, right? But again, it's procedurally generated. So something kind of cool. All right, so that is algorithm number 1. Today, you will have a chance to try some of these algorithms out if you wish to do so. And then part of your homework or your in-class exercise for a bonus is to use one of these algorithms to create a small, and I really mean small, procedurally generated level. Okay, and I'll talk about the details before we go and I start looking at using checkpoint 3 to take a look at all your team's examples. Okay, so let's take a look at the next part. So here's another one. So algorithm number 2, agent-based dungeon growing. I love this one. If I was going to make a little lit review, I would do it on this, agent-based dungeon growing. I love the names, right? Agent-based approaches to dungeon generation usually amount to using a single agent, so some kind of object that roams around the entire game world, and as they roam around, they dig through the game world to create the dungeon. That's a different way of doing it, right? So instead of the dungeon already being there, you have an agent that's going to discover the dungeon randomly, right? And the way this works is, here is the algorithm. Initialize the chance of changing direction. So this is your percentage chance of change, which is, let's say, is 5, right? Initialize the chance of adding a room. So adding a room, the probability of room adding, that's what this is 5. Place the digger, your agent, at a dungeon tile and randomize its direction. Dig along that direction. So basically what you're doing is you're exploring the dungeon, right, as you dig. And then roll a random number between 0 and 100. If the random number is below the percentage chance of changing direction, then you want to randomize the agent's direction, right? And so on. And you can see if you follow this little algorithm, it'll actually do something that looks like this, where you start off as an example, and then you go forward and you keep moving forward one step at a time. And what you're doing is you're exploring the game world and creating corridors and rooms by digging around and through them. So this is kind of a different way of doing it. Agent-based dungeon growing. Okay, kind of cool. And you can also make it so that it's less stochastic. Whenever you think about the word stochastic, in my mind it means random, less random. And you can prune some of this, the algorithm to be a little bit more managed or supervised, if you will. Here's another one. Place the digger at the dungeon top. Set the helper variables, right? So for rooms and for changing directions to 0, all right? For all possible room sizes, if a potential room will not intersect existing rooms, because the problem with this algorithm up here is there's nothing that's going to stop it from looping back upon itself. It can just go back the other way again, right? Because remember, it's just a random agent that's going to explore the world in random directions, and it could beam back. This is the same problem I had when I was showing you my first procedurally generated 3D level. It was what was happening. It was sometimes the agent would go back the other way around. So it's kind of, in a way, I was using this agent-based dungeon growing idea, all right, when I was creating my level. So if you do it the other way, if you have it more managed, as an example, then you get something that is less random, and it won't allow the agent to go back on itself. So if it's not going to allow you to create a room that's going to overlap with another room. Again, what it does for us, it creates a more organic look. But what can also happen is if this is your game world, you might get stuck or stop with a less generation, a level that hasn't taken advantage of the entire addressable space of the world, okay? Or your level, your chunk, your world chunk, right? You only take up part of the chunk. Why? Because, well, the agent turned back on itself, right? And because it's here, it can't go back, right? So that can happen as well. Again, this is the second algorithm, right? Algorithm 3, advanced platform generation. All right, and here is Spelunky, a very kind of fun game to play. At least it was for me when I first saw it in back in the day. And again, Spelunky took a different approach. So it was created by Derek Yu back in 2008, and what it does is it allows us to traverse 2D levels, right? But what we do is we get to the point where I want to go from one level to the other, and the way it's been created is something that looks like this. So Spelunky is divided into this 4x4 grid of 16 rooms. Okay, here's an example. Right now, you don't have to do it this way for our example. If you don't want to do that, you can make it a far less smaller thing. But each of these spaces is a room. All right, is a room. So you have almost like a pre-generated chunk ahead of time. Okay, a room chunk, smaller chunks. Okay, so instead of it being multiple levels, this whole thing is a level. Okay, as an example. Okay, so this is one level with different rooms that your camera can roam from one room to the other. In here, you might have the use of a static camera, so the camera may not move around like what we might see in other kinds of platforms. In this case, it does. But we may not see the camera movement the same as in other platformers where the camera is kind of a lazy following camera as much, all right? But what it does is instead of us generating everything, this is a semi-procedurally generated world. So where it says advanced platform generation, part of the level has been generated for you, right? And all you're doing is you're placing it. And not all the rooms are necessarily connected. In order to reach these rooms, the player needs to use bombs, which are a limited resource, to destroy the wall so that they can get to the room and complete the dungeon. All right, this is kind of the way that it would work, at least in the earliest versions of Spelunky. Spelunky 2 is a little different. Each room is selected from a set of room templates, or tiles, if you will, and which it's selected for, which is selected depends on where the room lies in the path. So sometimes what happens is, if we go back to this, you might have several different rooms that work in this slot, several different rooms that work in this slot, this slot, this slot, and so on. So you're going to get variation, right? But it's not infinite variation. And so this is more of a curated, procedurally generated kind of environment, okay? So you're going to get many, many different options here. So lots and lots of variation, right? But still not unlimited. What they do to make it even more interesting is that they can add little chunks into the existing level, right? Because remember, it's just a big tile map, each of these rooms, right? And so what you can do is you can create variation of each room by adding little chunks, right? And what they did was they gave the ability for you to add some variation in certain spots, right? So things like obstacles, some other things that are put in random places, so that each room themselves would be slightly different and would appear to be random, but actually it's the same room template with some minor adjustments. Okay, so that's what it was done. And then finally you get enemies, traps, treasures, and other props are added, so that way, depending on where they are, you might get enough variation to make it so that each room, although it's part of a template for that particular spot, so example, I may have chosen this spot here, we might have several templates that are available randomly to be inserted here in this spot when it's generated, when the entire level is generated, right? And then I add elements to make that room itself special, or with random loot drops and random stuff that you can pick up, again, which increases the replayability. Okay, so you can do something like this for your in-class exercise as well. I'm not looking for anywhere near the detail here. Okay, and we'll talk about what I'm looking for. Okay, it's not, don't be afraid. Okay, I'm not looking for like crazy detail like this. That would be insane for 2 days. Okay, all right, here's the last one that I'm going to talk about today. And you may have heard about this. You may have even used it in high school. Some high schools talk about something called Prim's algorithm for maze generation. Okay, Prim's algorithm is actually something that I learned about a long time ago. It's very simple, and it'll do a 2-dimensional maze. You can also use it for 3-dimensional mazes, but they're more difficult to do. Here's the pseudocode for it. It uses something called a spanning tree. All right, again, another tree type algorithm. It starts at one point and grows outward from that point, which is kind of very similar to what I did with my procedurally generated little 2D world we did last week. All right, so again, it starts at a point and then spans kind of in different directions from that point. So here's the algorithm. Choose a cell at random, add it to the list of visited cells. You have a list of visited cells. This is the current cell. Mark all the cells adjacent to that current cell, all the neighbors. Randomly select a marked cell and remove its connecting edge to a cell from the list of visited cells. Okay, so we remove a connecting edge. This is now the current cell. Repeat 2 until no adjacent wall can be selected, so you have no more walls that you can select. And while there are marked cells remaining, go to step 2 and keep repeating itself over and over again. By the way, the algorithm in its full bloom is available at this web link down here in the bottom. Okay. So let's start with a simple 3x3 grid. This comes right from the website. You start off with a grid like this. We choose a random place in the grid. Let's say here. For efficiency, let's call this the set of all cells that are not yet in the maze, but are adjacent to a cell that is in the maze. The frontier, we colored the frontier cells red, these ones, okay? And then what we do is, now let's choose one of these frontier cells, only one of these 3 cells as an example, at random, and carve a passage from that frontier cell to whichever adjacent cell is already part of the maze. So in other words, we choose one of these cells, we chose this one, let's carve a passage, let's remove the partition between the 2 cells, all right, to that part of the maze. Then we'll mark the neighbors of the formerly frontier cell as frontier. So in other words, I'm over here, I mark this one as frontier. This one, these ones are all marked as frontier already, okay? And then I'm here, I have to choose another cell. One of these red cells get marked. I choose this one, I mark that one, and I keep going until we complete the algorithm so it looks like this, okay? What this can do is it can create a massive maze, right, with start to finish, with some divisions and some dead ends. And this is a very common approach to creating mazes with Prim's algorithm. By the way, Prim's algorithm can be built upon. This can be a first pass. You've created your mazes and your walls. Now let's extrapolate and make it into 3D. Easy to do, right? Because now you have your divisions, okay? So, your mission, if you wish to accept it, right, is to take one of these algorithms and make your own maze random generator world. This is a GDW team effort, okay? It's not to be done alone or whatever. It's not in the smaller groups, but rather the bigger group, while I look at your do your checkpoint 3 with your teams. The other teams should really do things like this. And let me talk about the requirement for this one, because now we're moving into the actual assignment. So it's actually listed online. Let's go in there. Under assignment, you can see that there's an in-class exercise for lecture 10. This is where the submission is, as well as the details. If I edit it, you can see that I've got some text in there, and here it is. This is working in your GDW groups. Use any of the following algorithms presented in class to provide a procedurally generated level. All right, so again, some kind of maze generation with Prim's algorithm. This is easier, and it's recommended. Use this. You've got your algorithm. By the way, all the algorithms have pseudocode, and you can find all of them online. All right. Agent-based dungeon growing. This is a medium challenge. Okay, medium challenge level, because agent-based dungeon growing, you have to do some work with the idea of quote-unquote digging through your level and selecting neighboring kind of chunks, if you will. Think about them as voxels or blocks, and what you're doing is you're digging away each of the blocks or voxels to create your world, right? Spatial partitioning. I think this is very, very challenging for the 2 days that you have to do this. I don't recommend it unless you really are interested in learning about this. BSP trees can also be greatly, it's a great learning tool for things like graphics and collision detection and a bunch of other cool things. But again, giving you only a couple of days to learn this is really challenging, so especially for this being a bonus. Advanced platform generation I put here because it could be very challenging, but if you got a lot of help from your designer and your technical artists, this can be kind of fun to do as well. Or another procedurally generation technique. This example would be, I would accept Perlin noise. Please make your own algorithm though. Voronoi noise, which I've seen some people do before. Cellular automata, hard, all right, or harder, and etc. There's other procedurally generated or procedural generation algorithms out there that you can use to make something that's really cool. All right, next part, keeping everyone busy and having fun. This is what this thing is about. The level does not have to be playable, but it should have a reasonable structure. In other words, there must be a way of making it playable if I wanted it to. All right. In other words, if I dropped a character controller in the level, I could have some fun. It's kind of what we did last week. All right. If you have a technical artist in the team, they should create simple tiles or other assets that can be used for the game, or at least acquire them from the Unity Asset Store. So get some tiles so that you can use. A lot of times we want to do is we want to place tiles to make the dungeon more interesting, and it might help with the generation, almost more of a supervised generation as opposed to completely random. All right. Here's a couple of options. Option A, you can have only a portion of the level procedurally generated. In other words, have part of the level as static, that's been constructed statically. You can have your level designer or technical artist construct this level statically first, and then your programmers can go in and parts of the levels, they can use one or more different types of procedural generation techniques to fill in those levels with random stuff. All right, so that makes sense and that's playable. Okay, and I don't mean like random junk, like random game objects. That's not going to work. I want like actually some kind of platforms or tiles in order for you to make use of it. Option 2, by the way, you can combine these options. Okay, you can have your gameplay programmer drop in a playable character after the level has been generated. So you want to give extra time. Yeah, it says it's due tomorrow night. Yes, absolutely, because it says available until tomorrow, but due tonight. Okay, yes, it is. Let me make it so that's due. Let's make it available from the 20th and until the 21st. It's going to be due tomorrow as well. How about that? So no lateness. Okay, here we go. Thank you for that. Submission requirements. A zip archive of your Unity project uploaded to Canvas. All right, please remove the library files and anything crazy that's in there. A link to your team's GitHub repo. So the whole team is doing this thing, not just like one person. It's all 6 or 7 of you. All right, several screenshots from your procedurally generated level. So no video for this one. It's not that kind of work that I'm looking for. I want some screenshots, maybe in a PDF, or you can can show me what it looks like, right? Maybe a few words just to tell me what you did. That's it. All right. So that's what I want you guys to think about. I think it's a great exercise for you to get your brain going and to kind of include the whole team. It can be fun. I don't want you to spend an inordinate length of time on this. Okay, this is not a soul-sucking or time sink exercise. Okay, remember, this is just for a little bonus. All right, so I'm doing it for you guys to be interested, and I think it can work well with the topic that we're talking about this week. Sure, Roderick, I think it's good to at least have an observer, right? So I think it's, if you can look around the scene, or if you can even, I would even accept, Roderick, even if you can look at the scene from from the editor view. I'm okay with that. If you take an editor view, just like I did last time, where you press the button, let's say some kind of a button on the keyboard, maybe the R button to reset or respawn everything again. I'm totally fine with it. What I'm looking for is, hey, what did you get out of this? And you might want to show me the algorithms. Indicate which algorithm you use. Like, did you use Prim's algorithm? Did you use spatial partitioning trees? Good luck. Something else. Some kind of noise generation technique. What did you use? And then show me your results. That's what I'm looking for. Okay, and it's a team effort, and you can make it so that's more interesting. You can involve your team to do parts of it. Let's not make it too oppressive. It's not meant for this. It's meant for you guys to have fun. Okay, while we're doing something else. Questions around your in-class exercise for today? Again, I think it can be a lot of fun. Please don't look at it as a crazy exercise that I want no part of, Tom, kind of thing. It can be really interesting, and I think it's great from a takeaway perspective as well. Okay, so that's it for me for today from a lecture perspective. Now, next parts. What are we doing after now? I've given you a little in-class exercise. I'm into the next part, which is Project Checkpoint 3. I'm not going to start it right away. We're sitting at 3:45, all right? Over the next hour and 15 minutes, right? Or actually over the next hour or so, because I want it to go quick, guys, okay? So again, I'm going to go into each of the teams on Discord, so please join me on Discord. That's where I want you to go now. I'm going to keep our Zoom session active just to say for final words at the end. But most of the work we're going to be doing now is on Discord. I'm going to go back on Discord after this, right? And we're going to meet, right now it's 3:45. I'm going to give you a bit of a break to get a coffee, take a bit of a breather, all that kind of stuff. So let's meet back in, let's say, 10 minutes. So 3:55 we'll meet, and I'll start off with your your checkpoint 3. Now for checkpoint 3, this is what I'm asking for you to do. focus in on the requirements for this class. That's what I want you to do. Let's try and make it 5 minutes or so, not too long, so we don't spend the entire time. I kept you last week very long, like an extra hour. I don't want to do it again this week. I want to try and hone in on just the stuff that I'm looking at for my pieces. Show me your game. I don't necessarily need to see all the PowerPoint parts today, so you can say, hi, this is my team. Remember, we're making this kind of game, and let's go to the demo, like that kind of thing. And then if I have questions, if I need to slow you down, I'll slow you down. Okay, but focus on the demo, guys, so we can get this part done. Questions before we go and come back at 3:55. All right, so I'm going to stop recording now, and I'll see you guys back at 3:55